Hello, and thank you for joining us for the 2025 NASA Sea Symposium. We are NASA Sea's interns from the Astronaut Photography Research Team, and today we'll be sharing our project on evaluating anthropogenic or human-caused changes on Earth over time using astronaut imagery. My name is Krispa Chapagain, and I'm from Northfield, New Jersey.
I'm Cael Manning, and I'm from Caldwell, Idaho.
I'm Busby from Huntsville, Georgia.
I'm Pareena Gupta from Pleasanton, California.
I'm Ehrenkranz from Sammamish, Washington.
And I'm Dezarae Gonzalez from Westaco, Texas.
What is astronaut photography? Astronaut photography refers to images taken by astronauts aboard spacecraft, most commonly the International Space Station or the ISS. Astronauts use handheld digital cameras to capture these photos in the cupola, which is a 7-window observational module.
Now, why is it important? Well, astronauts can respond more quickly than automated satellite systems. They can take images of specific events like wildfires, floods, storms, often within hours of occurrence, making astronaut photography a powerful tool for monitoring rapid environmental change. While most traditional satellites take images pointing straight down at the Earth, astronauts can take images from a variety of angles and lenses.
So how did we find change over time? Our photos were collected from NASA's Gateway to Astronaut Photography database and supplemented using satellite imagery. Astronauts take millions of pictures, so we filtered using location, date, keywords, and time of day for city lights. We focused on finding images with low cloud coverage and high resolution from the exact same location and with discernible change.
Now, as said before, anthropogenic change refers to human-induced changes in the environment. Our project studies the impacts of anthropogenic activities, including urbanization, light pollution, deforestation, wildfires, aquaculture, and waterway engineering.
Now, I looked into the anthropogenic change in Tokyo, Japan. Layers of street and artificial light cover the Kanto Plain, which contains the Tokyo metropolitan area. This illumination characterizes the growing urbanization, exhibiting the population shift and growth. This pair of images shows the nighttime appearance of the Tokyo metropolitan area from the International Space Station from 2003 to 2021. In 2003, the photograph depicts the high light density in the central urban core and main transportation streets. However, in the peripheral areas within the greater metropolitan area, low light density and dark spaces are displayed. By 2021, the previously dim-lit areas and the central urban core are visibly packed with light density, suggesting growth in infrastructure, land, and especially population. The Tokyo metropolitan area's population was approximately 35.1 million in 2003 and grew over the years to reach 37.3 million in 2021. The dramatic increase in Japan's urban population, especially post-2000s, demonstrates a national trend of urban concentration. The rapid population growth required an increase in developed areas. Japan contains areas of high light radiance, with Tokyo standing out as a major contributor to regional light pollution, a consequence of dense urbanization. The new patterns of light showcase the continuous expansion of Tokyo's visible urban footprint. From an environmental perspective, the increased light usage is contributing heavily to light pollution. The high pollution concentration and the use of lights has also led to elevated temperatures. Thus, coming up with solutions to combat the challenges becomes necessary, as some urban planners predict there will be continued densification of the metropolitan area through the 21st century. Now, from here, I'm going to hand it over to Lloyd.
For my anthropogenic change, I looked at the Panama Canal, also known as one of the two most strategic waterways in the world. This marvel of engineering is an artificial canal approximately 40 miles or 65 kilometers long. Excavated by the United States in 1904 through 1914, the hollowed-out canal going through the Isthmus of Panama connects the Pacific and Atlantic Oceans, allowing water vessels to easily travel from the two, saving thousands of miles in time. In 2007, construction of a third set of locks began with the purpose of allowing larger post-Panamax ships into the canal. The 3 photos below show the change over time from before, during, and after the construction. Looking at the photos gives an idea of the process and shows how the surrounding areas have been affected. Furthermore, the canal has also boosted the economy and given Panama the new opportunities to grow. Next, I'll be followed by Cael and his anthropogenic change in aquaculture.
Aquaculture, which has recently attracted investment from Egypt, is the farming of aquatic organisms like fish, shellfish, and plants in controlled aquatic environments. It enhances Egypt's domestic supply and gives Egypt a more self-sustaining stockpile of food, reducing the need for imports and strengthening Egypt's source of more affordable protein. As you can see in the images on the right, The prime example of aquaculture development in the country is the Alfayrouz fish farming project. Along 17 kilometers the coast of the Mediterranean Sea, 5,908 fishing farm basins, each with an area of just under 2 acres, continue to produce over 13,000 tons of fish and shrimp annually. Alfayrouz's innumerable basins lie north of our large concrete production and industrial site east of the Suez Canal. Before construction, the region was composed of salt lakes and wetlands. Contributions to food production through large-scale aquaculture like Alfayrouz hold environmental risks, especially when not managed carefully. The conversion of wetlands disrupts their abilities to store floodwaters, protect and improve water quality, and keep water on the surface flowing during dry periods. Wetlands are relied upon by numerous bird and mammal species for resources such as food, water, and shelter. Furthermore, fish farming facilities can potentially harm marine ecosystems through the leakage of excess nutrients and chemicals into nearby waters. Without long-term measures such as salinity and waste management to function sustainably, projects such as the Alfayrouz could undermine the overall landscape. The next portion will be by Pareena.
I studied how the Mendocino Complex fire, one of the largest wildfires in Northern California, impacted the landscape over time. It ignited on July 27, 2018, and burned 459,123 acres of land. It included the ranch and the river fires, along with multiple smaller spot fires. The ranch fire started when a property owner struck a rock with a metal stake while trying to plug a yellow jacket nest underground. The cause of the river fire remains unknown. The image on the left was captured from the ISS and shows an active fire within the complex on August 4, 2018. The fire occurred in the wildland-urban interface, which is a zone where human development meets wildland vegetation. This overlap increases fire risk, especially when dry vegetation and hot summer winds accelerate fire spread. The two Terra satellite images shown were taken by the MODIS instrument and reveal landscape changes between 2011 and 2019 before and after the fire. The earlier image shows a landscape dominated by healthy forest and grassland, while the later image shows burn scars and exposed soil from the fire. The Normalized Difference Vegetation Index, NDVI, which ranges from -1 to +1, measures vegetation health. Higher values indicate healthier vegetation. NDVI maps show a drop in average values from 0.33 pre-fire, indicated by green patches, to 0.09 post-fire, indicated by brown-red patches. This indicates severe vegetation loss. Beyond vegetation, the fire also destroyed 280 structures, including 157 homes, killed 1 firefighter, and injured 4 others. It also burned through forested areas surrounding Clear Lake. While the lake itself was untouched, runoff likely carried ash and debris into the watershed, affecting water quality and aquatic ecosystems, as has been observed in other fires near coastal regions. Now I'm going to hand it over to Liz.
Thanks, Pareena. I researched change over time at Kutupalong in southern Bangladesh, which is the world's largest refugee camp. It has nearly 1 million inhabitants, over half children, with 800,000 arriving in August 2017 after a wave of violence against the Rohingya people, a Muslim ethnic minority of nearby Myanmar. The resulting expansion was visible from the ISS, as seen in these stacked images that depict the land before and after expansion. The camps are extremely densely packed, and structures made of bamboo and tarp provide minimal protection from floods, landslides, cyclones, and monsoon rains, which can occur multiple times each year. Now, this rapid development has also highly impacted the surrounding environment. This is a zoomed photo of camp roofs in 2023, and its effects are visible in the ecological condition map of the same area on the right. The camp is also built on the endangered Asian elephant's migratory route, leading to attacks on both sides. A study from a university in Bangladesh found that an 8% increase in settlement area brought an almost 10% decrease in forest area. This leaves the region unprotected and further susceptible to desertification and severe floods, while overused wells deplete groundwater and affect vegetation. Deforestation has also led to a 14.6% decline in biodiversity. The camp population is currently relatively steady, but these environmental and humanitarian challenges persist due to limited aid and no safe place for the Rohingya to return to. Next, Dezarae will be sharing her project.
I researched change over time on Florida's unique coastal environment. This territory is shaped by constantly shifting sediments, primarily composed of quartz sand and calcium carbonate, essential for maintaining water quality and supporting marine life. Over the past decade, Florida has experienced a sharp increase in urbanization, particularly in southeastern regions fueled by population growth, tourism, and coastal development. This surge, averaging 1.4% annually between 2010 and 2020, has disrupted natural sediment processes and increased runoff into coastal waters. NASA images of Sewall's Point from 2009 to 2017 visually capture this transformation, showing how unchecked development contributes directly to sediment buildup and environmental degradation on the Florida coast. The 2020 U.S. Census map below highlights this growth trend, showing how major metropolitan regions such as Miami-Fort Lauderdale, with over 6 million residents, contribute to increasing pressure on Florida's fragile coastal systems. Additionally, the graph located on the right displays a steady rise in Florida's resident population from 2000 to 2034, with a noticeable spike in growth during the 2010s, when population climbed rapidly from 18.8 million to over 20.4 million residents. This urbanization impacts the environment by disrupting natural sediment movement, smothering seagrass beds, and degrading coastal ecosystems. As development continues, habitats like coastal uplands face the risk of losing nearly half their area by 2070, threatening biodiversity and weakening natural storm barriers. In conclusion, when observing Earth from space, the impacts of human activity are visible on a global scale, from Bangladesh in South Asia to Panama in Central America. Anthropogenic changes affect nearly every community and environment.
While some of these changes may offer short-term benefits, the continued, unchecked expansion of human influence on natural systems has already led and will continue to lead to significant long-term consequences. Earth observation from space provides essential context for us understanding the extent and impact of these transformations on the planet's systems.
When researching information for our project, we found that some of the hardest tasks were finding photos and data sets to match our topics. There are thousands of photos that have been collected and documented over the last few decades on the Gateway to Astronaut Photography of Earth website.
Filtering through the images to find two or more that depict the same exact coordinates over a sizable time period proved to be quite difficult. In addition, some of our topics required very specific related data that took a while to find to help explain what was going on.
Now we've had a lot of memorable experiences throughout these 2 weeks, from touring the Neutral Buoyancy Lab, the Johnson Space Center, and intense high-spirited card games. We've also had the incredible opportunity to meet astronauts, engineers, and professors from all over the country.
Looking back, every single moment has expanded our knowledge in STEM. These 2 weeks have led to an unforgettable and enriching internship experience.
NASA Seas was truly a life-changing internship. From learning how to write my first scientific article to expanding my social skills by meeting just under 100 interns and mentors these last 2 weeks, NASA Seas has tested me in every aspect.
The NASA Seas internship has been a transformative experience. This program has expanded my professional network, deepened my passion for STEM, and opened doors to opportunities that I once thought were out of reach.
Although I've learned a lot about aerospace, this program has also shown me the breadth of intersecting fields and amount of collaboration that goes into any space venture. It's motivating and inspiring to know that no matter what I end up pursuing next, there is a place for my interest in space.
Having the opportunity to be a part of the NASA Seas internship was a remarkable experience that has positively challenged me in both academic and social aspects.
Seas was an amazing experience. I've learned so much and I'm so grateful for all the people and knowledge I have gained.
Throughout the 2 weeks of Seas, I've had an incredible experience, bringing me out of my comfort zone and teaching me so much. I am so thankful for the opportunity and for the amazing people I got to meet.
Thank you to our mentors, Rossina Miller, Flor Estella Gomez, Margaret Baggio, Selena Miller, and Laura Tomlin. We also want to give a big thanks to SEAS, NASA, Center for Space Research, NASA Johnson Space Center, and the University of Texas at Austin. Finally, thank you to everyone in the audience here that has supported and listened to our presentation today.
Thank you!